see in the WhatsApp group particular study material as our text and reference. I could suggest you the name of the book also. It is Highest Surveying by Professor Piyush Shom and Professor Bholanath Ghosh. Both have been legendary professors of the same department you are studying in right now. Unfortunately, the book, perhaps the printed version of the book is out of the market right now. I have given you the scanned copy. If you get it from somewhere, please keep the whole book because it is worth having.
Sir, can we get it from the library?
I hope so. It should be available in the library. Or by now you are familiar with the Xerox centers just opposite to our university. Just behind the bus stand. Go to them and ask for this particular book. Perhaps they have got a copy of it. Sure. In fact, you have to record it because maximum capacity of joining is 100 people. And your class strength is much greater than that. So you have to share the recording with them. And I have already told Protoy to record the attendance because in a 1 hour class, it will be impossible for me to take daily attendance. Otherwise, valuable class time will be lost. Okay. 58 people has joined so far. Is the screen visible to you? Could you see this particular figure?
Yes, sir.
Yes, sir.
And this document? Both of them are visible.
Yes, yes.
Fine. The question I ask before every surveying class is that what is your concept about surveying? What is surveying?
Prepare a engineering map.
Anything else? This is surveying too, so you are already familiar with conventional methods of surveying. That is chain compass survey, theodolite survey, all has been already taught to you, right?
Sir, surveying is the way to determine objects on a map for making the structure.
Okay. Let me know. I think your batch have not been able to perform any practical class, right?
No, sir.
Surveying is purely a practical subject. You have to perform the thing on the field. So unless and until you do so, it will be impossible to grasp the potential and the true nature of the subject. However, all of us are facing these limitations. Okay, the thing you are telling that surveying, the deliverable of surveying, the purpose of surveying is to prepare a map. Can we agree on that?
sir.
And what is required to prepare a map?
The horizontal distance.
Vertical distance? Is it not required?
So, vertical distance is taken for leveling.
That is surveying also?
Yes, sir.
Relative distance.
Yes, you can say that. What is a map from surveyor's point of view? What is a map from surveyor's point of view? Or a plan?
Sir, area of the surface which is scaled down for us for easier work. That is map.
Yes, I like this particular term, scale down. I prefer to call it a scale down representation of spatial reality. It is a representation of reality. What kind of reality? Spatial reality, reality of the space, represented as a scale down version. Say, for example, the map of India. Just think of the geographical boundary. It is, of course, representing the shape of actual boundary, political geographical boundary of India. So it is representing reality. It is representing in a scale down version. And what kind of reality it is representing? The space. So to draw anything on space, say a line, what this boundary of India is constituted of on the map, of course, a line or combination of lines, and to draw it, what we require? To draw any line, what we require?
Length of the line.
The coordinates of the line.
Coordinates of the line, what does it mean?
Call it a point. Which point we connect to draw a line.
Could you see the map of India on your screen? The Google Earth map?
Yes, sir.
Fine. So these yellow lines are constituted of joining several straight or curved lines. To create those, what is required? To draw any line, what is required? To draw any line, we need to ascertain the points constituting the line. So basically, we are scaling down to our whole discussion to ascertaining the position of points on some spatial coordinates. Right? That is the basic principle of surveying. Somebody has mentioned that for surveying, for preparing maps, relative positions of different points on different planes are required. Of course, it is required. And so far, whatever surveying you have learned, the conventional methods like chain compass, like theodolite, like leveling, in all of these, you have basically learned how to do this thing. That is to ascertain, to measure, to represent relative positions of different points on a particular plane. So far you have done that on two-dimensional planes, for plans, for maps, for all the horizontal measurements, that is done on the horizontal plane. For leveling, we have done the same on vertical plane. And with those methods, we have finally prepared the plan of the map. Now, as the systems are advancing, as the technology is advancing, this kind of conventional measurements are of course necessary, particularly for civil engineers, but other means, other easier means are now available to us, as one of them is already open to your screen. So if I simply type Jadavpur University here, the entire map of the entire area just a second. So the map of the entire area is now visible, and this particular building is our very own Projukti Bhavan, hosting the civil engineering department. So we could take all kinds of measurements here itself and see in a top view how the entire area looks like. It does not require any of the conventional methods to prepare this particular image. This particular image is made up of combining several images taken from satellites. So our surveying work, with the advancement of technology, has now to come to this extent. Of course, we are not going to study here the satellite imagery. Perhaps GNV sir is going to teach you the remote sensing and GIS part. What I am going to teach you here is the science of this photographic survey. That means when the surveying work is carried out by taking photographs of an area either from ground or from air. So our area of study will be photographic survey or aerial survey. Mind it, this satellite imagery definitely is a part of, more advanced part of this photographic survey. Is somebody waiting? No. From the next class onwards, unless and until I tell any modification in that class timing, after 10 minutes from starting of the class, I will not allow anybody to enter. Okay? No. Here is the definition of photogrammetry. Photogrammetry is the science of taking photographs of the Earth's surface for the purpose of surveying. As I have already told, the photographs could be taken from the ground. Photographs could be taken from air. Precisely, here we are going to study the science of aerial photogrammetry. Aerial photogrammetry could also be of two types. Let us see. After adjusting the tilt of the photograph, the kind of photograph we are seeing here is a vertical photograph. What is a vertical photograph? When the plane of the photograph or plane of the sensor of the camera is exactly parallel to the plane of the surface for which we are taking the photograph. So this is a vertical photograph. There could be other kind of photographs also. Just a second. As you can see here, walls of these buildings are visible, right? Had it been a purely vertical photograph, we could have only seen the rooftops or the footprints. So the photographs we are seeing here might not be purely vertical ones. This kind of photographs are called oblique photographs. I am taking two images and send it to your WhatsApp group. Just see it. This is my tabletop. Just a second. Could you see the photograph sent to your WhatsApp group?
Yes, sir.
You have to keep your WhatsApp on. So this is the photograph of a pen vertically held on my desktop. The photograph is taken more or less vertically, keeping the photographic plane horizontal to the desktop parallel to the desktop surface. So the pen is looking like more like a dot. This is a vertical photograph. Instead, what we could do, if we could take the photograph like this, the second photograph, it is being sent to you. It is a photograph of the same, right? Could you see it?
Yes, sir.
The only difference with the earlier photograph is this photograph is not a vertical one. It has been taken sidewise with some inclination. This is called an oblique photograph. Depending on the inclination, the oblique photograph again could be of two kinds. If we just simply imagine, see all these photographs that are visible on the screen are called low oblique photographs. When these are called low oblique photographs, when the horizon is not visible. I am taking a third photo of the same pen. This is again an oblique, but the difference with the earlier oblique photograph is now you could see the edge of the desk. If we simply imagine the edge of the desk as our horizon, then in this আসেনি
আচ্ছা এটা অডিও এসছে
অডিওটার পরে গেছে
Yes, sir. Yes,
just see the edge of the desk is now visible in the photograph. Imagine that the desk surface is our earth surface and that edge is horizon. So in those oblique photographs where the horizon is visible are called high oblique photographs. In our course of study, basically we are going to study two kinds of photographs. That is either vertical one, the very first one, or the low oblique photographs with less inclination. Okay. So, with this brief introduction, let us get acquainted with a few terminologies. Unfortunately, the blackboard is not available. So this is my limitation here. Limitation to you also. So you have to imagine a bit. This is the representation of an oblique photograph. Let us try what is what. As you can see, this dotted plane is the horizontal plane. Let us consider it as ground. The inclined plane, this one, is the plane of the photographic plate. Is the figure clear up to this?
Yes.
This plane is, just follow the cursor. This plane is horizontal plane, and this is the inclined plane of the photographic plate. When extended, these two planes are meeting at this particular line. And as you can see, the plane of the photographic plate is inclined to the ground plane by an angle theta. Now, there is a point in this three-dimensional space enclosed between this ground plane and the inclined photographic plate, denoted as point O, this particular point. This point O represents the optical center of the lens through which the photograph is being taken. O represents the optical center of the camera lens with which the photograph is being taken. Is it clear up to this point?
Yes, sir.
The construction of the figure is very important. You have to understand it. Okay. Now, what we have done, we have drawn another plane parallel to the ground plane. This is the ground plane. We have drawn another plane parallel to the ground plane, passing through point O, which intersects the photographic plate at a line H1, H2. This is H1, this is H2. Is it clear? Is it clear up to this point?
Sir, can
Yes,
you
sir.
repeat once?
Yes.
Okay. I'm just opening the camera. Could all of you see this attendance register I am holding?
Yes, sir.
Yes, sir.
Yes, sir.
Imagine this particular plane as the ground plane, and this inclined plane as the photographic plane. Okay?
Okay, sir.
Okay? Fine.
Okay.
Somewhere here, just see the position of my fingertip. Somewhere here is the optical center of the lens. Through it, I am drawing a plane parallel to the ground plane. So that plane is going to intersect this photographic plate at a line.
Yes, sir.
This is H1, H2. This is the H1, H2. So this is clear. Let us draw a straight line right through point O, that is the optical center of the lens, which is perpendicular to the photographic plate. I am talking about this particular line, OP. OP is going through point O, and it is perpendicular to this inclined plate. Again, just see the camera. This line. the pen. It is OP, perpendicular to this particular plane, photographic plane.
Sir, can you hold the camera a bit low? It is high.
Now visible?
Yes, sir.
My fingertip is point O. The pen is passing through that point and is perpendicular to this inclined plane. Okay?
Okay, sir.
This line is called the photo principal line. This line is called the photo principal line, and it is cutting the photographic plate as at point denoted by small letter p, and when extended, it is cutting the ground at a point denoted by capital letter P. Again, just think of this, something like this. So if it is a photo principal point, could you see the pen?
Yes, sir.
Yes, sir.
This is optical center O. This is our photo principal line. That line is cutting the photographic plate here and the ground plane here. These two are called principal points of the photograph. These 2 points are called principal points of the photograph. On ground, it is called ground principal point. On photograph, it is called photo principal point. And together they are called conjugate principal points. Generally, all the ground points will learn about several such conjugal points. Generally, the points on the ground plane are denoted by capital letters, and corresponding points on the photographic plate are denoted by small letters. So, now we know this is the photo principal point, small letter p, and this is the ground principal point. Now we'll learn about the second set of conjugate points. We'll simply draw a vertical line through the center of the lens through point O. The earlier line, the principal line, was drawn perpendicular to the photographic plane. This line is drawn perpendicular to the ground plane, a vertical line, but of course passing through the optical center of the lens, O. This particular line is called the plumb line of the photograph. And again, it is cutting the photographic plate at small letter V point and ground plane at capital letter V point. This line is called the plumb line, and these 2 points are called the plumb points. Of course, the small letter V point is called the photo plumb point, and the capital letter V is called the ground plumb point. Up to this, is it understood? Is it clear?
Yes, sir.
Yes, sir.
Now
So,
I am in the third pair of conjugate points, which is very, very important. As you can see, the principal line and the plumb line again are inclined to one another, making an angle theta in between them. The same angle of inclination. I need not explain this. Angle of inclination of this plate with the horizontal will be same for angle of inclination of the line to the photographic plate with the vertical one. So if this angle is theta, then this angle will also be theta. Understood? Now I am drawing a line bisecting this particular angle through point O. I am drawing a line bisecting this angle theta through point O. This line is going to cut the plane of the photograph at this point, denoted as small letter I, and the ground point here, denoted as capital letter I. These 2 points are again a pair of conjugate points and are called isocenters. These 2 points are called isocenters. Of course, this point is called photoisocenter and this point is called ground isocenter. What is the typicality of this particular point? As you can see from our simple trigonometric knowledge, just follow my cursor. If this angle is theta, then this angle is also theta. Isn't it?
Yes, sir.
If this angle is theta, then this angle is going to be 90 minus theta. We have already said that this particular line is bisecting this angle theta. So each of these 2 angles are theta by 2. This angle is theta by 2 and this angle is theta by 2. And angle concurrent to this angle is again theta by 2 and this angle is again theta by 2. The principal line being perpendicular to this plane, this angle is 90 degree. This angle is 90 degree. And if this angle is theta by 2, this angle being 90 degree, this angle is going to be 90 minus theta by 2. Right? Right?
Yes, sir.
Yes, sir.
Yes, sir.
Now consider this particular triangle, OVI. For this particular triangle also, this angle is theta by 2. This angle is 90 degree. So this angle will be 90 minus theta by 2.
Yes, sir.
So for this triangle, small I, D, capital I, both of these triangles, both of these angles has the same value, 90 minus theta by 2. Right?
Yes, sir.
Yes, sir.
So this line joining the isocenters is at such a line which is inclined to both the ground and the photographic plate by same amount. So this particular line is inclined to both the planes by the same amount, 90 minus theta by 2. This is of particular importance. When we are going to find out, see, for all kind of maps, scale is very important. Scale is very important. Unless and until we know the scale of the map, that map is useless for any practical purpose. So we must know the scale of the photograph also. See in this Google map, could you see this bar?
Yes, sir.
Yes, sir.
This represents the scale. So this much length is representing 153 meter on ground. See, the scale is changing as I am zooming out. The same length is representing more and more distance. And as I am zooming in, it is representing lesser and lesser values. So we have to know the scale of them. How to find out the scale of a photograph? Let us take a typical vertical photograph, unlike the one we are considering right now. It is an inclined photograph. These are typical vertical photograph. Where the photographic plate is absolutely parallel to the ground surface. We are taking photo of an area enclosed between these 2 points A and A dash on the ground. By simple optics, simple geometry, the same area is represented on the photograph as small a dash. And what will be the scale? What will be the scale? It will be A dash divided by capital A dash. Right?
Yes, sir.
Yes, sir.
Fine. Now, from the properties of similar triangles, as you can understand, both these triangles, the upper one and the lower one, both these triangles are similar to one another. What is the property, most important property of similar triangles? Ratio of the similar sides are equal, right? So let us consider this. Let us consider these two triangles: capital O, capital A, capital V, the bottom one, and capital O, small a, small b. These two triangles are also similar. So basically,
Yes, sir.
for determining determining the scale, we are going to find out the ratio of these two similar sides, small AV divided by capital AV, but that is equal to capital O small v divided by capital O capital V. Small AV divided by capital V should be equal to capital O small v divided by capital O capital V. Is it correct?
Yes, sir.
Yes, sir.
But what is capital O small v? This distance. This is the distance between optical center of the lens and the photographic plate. So this is the focal length. This is the focal length of the lens, denoted as small f. And what is this distance? Capital O capital V. This is the height of the optical center of the lens from the ground, or height at which the photograph is being taken. It is denoted as capital H. So the scale of the photograph is small f, that is the focal length, divided by capital H, that is the height of the photograph. Right?
Yes, sir.
Right?
Yes, sir.
Yes, sir.
What will happen for an inclined photograph like this? For an inclined
ওটা থিটা
photograph
টার্মে
like
চলে
this.
আসবে, মানে ও আই ওটার যেটা ফোকাল লেন্থ থাকবে আর বাকিটা থিটার টার্মে।
Here, exactly. Here, the scale of the photograph will be capital O small p divided by capital O capital P. How much is capital O small p? This is the perpendicular distance photographic plate. So this is the focal length. And this capital O capital P, how much is this? If this angle is theta, then capital OP cos theta will be H, cos component of OP will be H. So OP cos theta will be H, or OP is H sec theta. So the scale of this inclined photograph will be OP divided by capital OP, that is F divided by H sec theta, right? Up to this, is it clear?
Yes, sir.
Fine.
Yes, sir.
Then we have two clear distinctions. For vertical photograph, the scale is represented as F divided by H. For inclined photographs, oblique photographs, the scale is represented as F divided by H sec theta, where theta is the angle of inclination. Right?
Yes, sir.
Yes, sir.
Now let us examine what happens when isocenter is considered. When the isocenter is considered. Let us see. The scale along the isocenter image of the eye, ground isocenter, is formed at here, small I. So for this image, The scale of the photograph is O small I divided by O capital I, right?
Yes, sir.
Fine. Now, O small I is how much? This angle is 90 minus theta by 2. This angle is 90. So this angle is theta by 2. So OI cos theta by 2 is OP. OI cos theta by 2 is OP, or OI is equal to OP sec theta by 2, but OP is the focal length. So OI is F sec theta by 2. Now consider the capital Y. How much is it? This angle is again theta by 2. So OI sec theta cos theta by 2 is capital H, or OI is equal to H sec theta by 2. So O small I is F sec theta by 2. O capital I is H sec theta by 2. So scale of the photograph along this isocentral line is O small I divided by O capital I, that is equal to F sec theta by 2, H sec theta by 2. From both numerator and denominator, sec theta by 2 cancels out, and the scale becomes F divided by H. Right?
Yes, sir.
So this is the beauty of the isocentric line. Along isocentric line, scale of the photograph, even for an inclined one, is equal to the scale of the vertical photograph. That's why this line and these two conjugate points are very, very important. Okay.
Yes, sir.
We are going to conclude today's discussion. Just a second. We are going to conclude today's discussion saying the last thing, that is, for a vertical photograph, 3 pairs of conjugate points coincides with one another. You cannot differentiate between these two. So plumb point, isocenter, plumb point, isocenter, and principal point. For a vertical photograph, these 3 points becomes one single point, coincides with one another. You cannot distinguish between these two. Okay. So that is the typicality of a vertical photograph. So this much for today. If you have any doubt, please ask me. No problem with that. We are going to meet again on next Monday.